So here we have the 12.1 homework, basic probability, and there's some vocabulary in here that your book doesn't quite define. Disjoint is a common word. Disjoint is another word for independent or mutually exclusive. And if two events are mutually exclusive, let me adjust this font size here so I can fit it all in here. Then the probability of A or B is simply the probability of A plus the probability of B. It's not too hard. So if I was going to do either one of these, if I want to know what the probability of A or B was maybe on number 4, I would just do 0.11 plus 0.19, and I would get 0.3. Seems legit. Overlapping is another word for dependent or not mutually exclusive. And of course it has a different formula too. It says the probability of events A or B is the probability of A plus the probability of B minus the probability of both. And that little guy right there, that last piece, is the overlap, where they both come together. So if I want to do one of these that has overlap, I would just follow the little formula. I do subtraction. Oh, and I kind of wrote this the wrong way according to this worksheet here. If I wanted to find the probability of both, these are both the same formula. Things have been manipulated. This is the one that's required for these though. I need this right here. So if I want the probability of events A and B, I would add these two together and I'd take away that or statement. Probability being one or the other. So this one would be 0.4 plus 0.3 minus 0.2. Which is 0.5. Pretty simple. It's just formulas. A bag contains 10 pieces of paper numbered 1 through 10. You draw one piece of paper at random. Find the probability of A or B for the given events. Event A is that the number is even. Event B is that the number is prime. So if I think about my sample space here, even numbers would be 2, 4, 6, 8, 10. Prime, which I know throws a lot of kids off, the lowest prime number is 2, then you have a 3, then you have a 5, then you have a 7. Now one thing I do notice here is there is some overlap. But they both contain a 2. Now, let's talk about probability. The probability of event A looks to be like 5 out of 10, which is 0.5. I think I see 5 numbers here. The probability of event B looks like 4 in 10 events, 4.4. There is overlap. They both contain the 2. So that's a big deal. That overlap has to be taken care of. The overlap is the 2, which is 1 in 10. And the overlap has to be taken care of. You can't count the same thing twice. So the probability of A over B is going to be the 0.5 plus the 0.4 minus the overlap of 1/10. And that is 8/10. There you go. That handles that. Part of me wants to assign some IXL for this because IXL actually has some half decent probability stuff in it. The spinner is divided into 12 equal parts. Given events A and B, find the probability of event A or B. Ours one in here is probably 10 or 11. Let's look at 11. 11's the hard one. Event A is the spinner lands on a number less than or equal to 4. So it could be a 1, it could be a 2, it could be a 3, it could be a 4. And there's 12 parts, so the probability of event A is 4/12, which is 1/3. Event B is the spinner lands on red, and I see three things. I see a 2, I see a 6, and I see a 4. And the probability of B is going to be 3 in 12 things, which is 1/4. Now there is overlap. The overlap is the 2 and the 4. So the probability of the overlap here is going to be 2 of 12 things, which is 1/6. So we're going to follow our little formula where we take away this overlap. And I want the probability of A or B. Probability of A or B is going to be the probability of A plus the probability of B minus the probability of both. So the probability of event A is 1/3, probability of event B is 1/4, and we're going to take away the 1/6. Just because we can, we're going to make these all the same fraction. Maybe I should go back to my 12ths up here. I had 4/12 plus 3/12 plus 2/12. Sorry, that's supposed to be a minus. And 4 plus 3 is 7, minus 2 is 5. So 5/12 is my final answer. Alright, a blood bank records the blood types, including positive or negative, during a blood drive. The table shows the number of donors with each type of blood. 13 says, find the probability a donor chosen at random has type A blood or is positive. So here's type A blood. Type A blood is 160 out of what, 400? So probability of event A, which is, let me define that. Event A is A blood. And it looks like there's 160 out of 400. Or is positive. That's going to be event B. If I scan across here, there's 331 who have positive blood type. Out of 400. And I want the probability of A or B. I do want you to note that there's overlap. It's right here. So let's talk about the probability of the overlap. It's 134 out of 400. So therefore the probability of events A or B is going to be the probability of A plus the probability of B. Take away the probability of the overlap. Alright? That's the A and B part. So event A was 160 out of 400. Event B was 331 out of 400. Then we have to take away the overlap space of 134 out of 400. And then we do the math. There's another way of doing this. You could just count everything that it wasn't. 37, 43. It should be 43 out of 400. Sorry. That's not right. I don't know what I was thinking there. Anyways, we got 160 minus 134, which is 26. 331 and 26 makes 357. Yeah. 357 out of 400. Crazy, huh? Now I think that makes sense. 26 and 11 makes 37, makes 43. So there's only 43 people who did not meet either requirement. 400 minus 43 is 357. All right, this page, the estimated percent of age distribution of the U.S. population for 2010 is shown in a circle graph. Find the probability that the person chosen at random fits the description. Of course, we have some wording here that's going to bother you all. Like at least 15 years old means 15 years or higher, right? That's what it means. So I think I'm going to be adding, one way I could do this is I could take 100. I could use a complement. It is easier to use a complement. The complement of 15 years or higher is going to be less than 15. So less than 15 is going to be 7% plus 13%, which is 20%. Now, if you don't want to use the complement, well, you're going to have to go through and you're going to have to add everything together. There's a 14%, there's a 13. It happens twice. Then I got a 15, a 12, a 13. No, I didn't finish this. Now, if we do 100% minus 20%, we get 80. Sorry, I don't know why I didn't finish that. Must be tired. We have 13, 13, and 13, which makes 39, right? We've got a 14 and a 15 and a 12. 14 and 15 is 29, plus 41% there, and that's going to be 80%. Either way you look at it. So those aren't too bad. Circle whether the events are disjoint or overlapping. Remember, disjoint is independent, overlapping is not mutually exclusive. A card is randomly selected from a standard deck of cards. What is the probability there's a queen or the ace? That is definitely disjoint. Those have no effect on each other. No effect whatsoever on each other. Hopefully I didn't just lose my audio there. I'm unplugging something. Let's make sure I didn't. Can you still hear me? Cool, can. But anyways, these events are disjoint. And we do see the word or, and the word or means add. That's what it means. Probability is a queen. There are 4 queens in a deck of cards, and there are 4 aces. So there's, if we think about it, there's 8 total, but there's 4 and 52 plus 4 and 52, which is 8 and 52, which reduces down to, what, 2/13? Yeah. Yeah, that's right. 2/13. A lot of kids don't know how many cards are on a deck of cards. You roll a 12-sided die that has faces numbered from 1 to 12. What is the probability that in a single roll you roll an even number or a multiple of 3? So this is where we write out the sample space here. It could be a 2, a 6. This will be event A. An 8, a 10, or a 12. Event B is going to be the multiples of 3, which will be a 3, a 6, a 9, and a 12. Now the reason I write these things down is so I can find the overlap. That's why I do these. There is overlap. There's no doubt about it. The overlap is going to be the 6 and the 12. So we're going to go through and encounter things. Here we have 5 of 12 things. Here we have 4 of 12 things. And the overlap is 2 of 12 things. So the probability of A or B is going to be 5 twelfths plus 4 twelfths minus the overlap of 2 twelfths. And that's going to give us 7 twelfths. Alright, the last little thing in here I think is just dealing with complements. It says find P of A bar. It's asking you to find the complement of the probability of A. And the complement of the probability of A would be simply 1 minus P of A. So here, the complement of A is going to be 1 minus 0.37, which is 0.63. That's how you do those. They're not hard. Using complements, you roll a two-sided dice. Find the probability of the given event. Alright, so first off, we're going to let event A be the sum is 4. Because that is the complement would be sum is not 4. Alright, so let's find the probability of event A. The sum is 4, and I can think of how many ways I can do this. To do this, I'd have to have like a 1 and a 3, right? I could be a 1 and a 3, or I could be a 2 and a 2. Now, there's a little more to this. I could be a 1 and a 3, or I could be a 3 and a 1. Or I could be a 2 on one place and 2 on the other. Doesn't really affect anything. So there's 4 ways for this to happen. Out of 12 total events. It's a two-sided die. There's 6 events here, there's 6 events here. So there's 4 ways in 12. That's what I'm thinking about. 4 ways in 12. Or 1 over 3. So the complementary event here is simply going to be 1 minus a third, which is 2/3. And there you go. That's it. Good stuff. Alright, on to the EOC stuff. The company wishes to determine the cooking time for 1 pound of spaghetti. The company's technicians cooked 1 pound of spaghetti and recorded the time needed for the spaghetti to be ready to eat. They repeated this process 35 times, resulting in an approximately normal distribution with a mean of 9.82 minutes and a standard deviation of 1.4. In which interval should the middle 95% of all cooking times fall? So this is the lesson we did yesterday. This is your whole margin of error thing here. Your confidence interval this is a 95%, is going to be the mean plus or minus 2 standard deviations over the square root of the sample size. So the mean is 9.82. We have 2 times 1.4, and it's sitting over root 35. That's what it is. Fire up my TI-84 here. 9.82 plus 2 times 1.4 divided by the square root of 35. I'm looking for a 10.29, which is in choice 3. Now, let's see what happens if we just let the TI-84 do all of it. Let's see, what was that, second vars maybe? No, wrong place. Go to Stat, Tests, Z interval. Going to use descriptive statistics. We have a standard deviation of 1.4. We have a mean of 9.82. We have a 35 sample size. We have a confidence interval of 0.95. That was the bell, so I'll have to stop here. Still the closest one, isn't it? So there you go. And I'll stop there and I'll finish this video during my planning period or lunch break, one of the two.